like that today, but there you go. Here's our start of the video. Nidden, if you're watching these, we miss you.
We miss you, Nidden. Please come home.
All right, so I got you. Give me just a second. We today are here. What? It was up there.
Yeah. Why do you have my plan book?
It's the standard review for you.
I knew it.
No, it's the entirety of HSM2.
It's every problem in the entire book. Due tomorrow.
There goes the table.
Yeah, I know. It's still not like
where he works.
it just
Some
sits
people
on
stay
there.
over at work till 2:30 in the morning. Working.
Everyone has those situations. All I'm saying is that's an opportunity to grow and tell yourself like, okay, I had a late night, rough night, whatever, but like I got to do this.
No, like what I was just.
So Chris, should I have to ask you what I'm about to ask you? Get out some graph paper. Get ready to work.
Will we need the anterior angle sum of polygons resource page thing? Yes.
Yeah, I don't really think so, actually.
Also,
Today we're moving on to areas.
what happened to Steven? He died.
He's going today because he's at another like special event sort of thing. I forget exactly which it is. But yeah, Steven, if you watch the video, hope things went well today. You might want these because today we're doing area of different shapes, and a straight edge is always useful. Help draw these things up. I, as much as possible today, am not going to help you. And to be honest, that's one of the hardest. To be honest, that's one of the hardest things about being a teacher, is when I can't help you. Now, this is a complete flip from back in the day. Teachers, like primarily, was you showed up, you sit down, shut up, listen, take notes, whatever. Like it would often you would hear teachers say, "Sit down, shut up." Like that's not how we want this to be, right? So what we're doing today is finding the area of polygons using the strategies that we've built up through this year, and we're pushing you to use multiple strategies. My smartboard's very messed up today, so it's not going to be very useful. So you and your team, and really just you guys as a whole class, are working first to find the areas of both of these shapes, but in two different ways. So if I were you, I'd probably just sketch out two of each of those, and then be able to.
There's a square on here.
There's a square on there.
Where?
Number 3.
The third one over from the
I
top.
thought that was a
Middle.
wrong. I was looking weird.
Oh.
Wait, you
Now,
thought this was a wrong.
what you will notice is every problem today is structured a tiny bit differently to the skills that you will need to pull out of your toolbox and reutilize here. So the square, as I'm sure you can already see, is broken up, but depending on how you want to look at it, it's broken up in a couple different ways.
Wait, do you have to actually solve it, or can we say how you would solve it?
Yes.
Wait.
What?
So your task, if you so choose to accept that you have to,
We have to.
is, well, then go to the office and sit things out.
Dang.
You just can't be nowhere. You have to like be somewhere. Your task is to be able to justify in two different ways how you found the area of the square, then how you found the area of the hexagon, then if you get done, and I'm not going to make you guys create a presentation. I may ask that we show what work you have on the dot camera, if you're comfortable with showing people your work. Then these will push you a bit further. Now those I don't guarantee are on your template. Be careful, count sides before you start. Notice that A has a point at the top, B does not. They're not the same shape.
Find the length of that side, and then you can do that. Yeah. Okay.
Now, here's my request. If you share a method with your team of like what Satya just did, you can't be the one to share the second method. You have to give your team, somebody else, the opportunity to say, we could also do. Then you're generating all of them.
Alright.
Yes.
So all of this then?
I am not. I am. Unless you've already asked a classmate, I'm not answering your question.
There is no way that every single side could be 6.
The diagonals are 12.
Wait, Chris, so you could make this 6 and 6, and you could make that.
That'd be 8. This would be 8.
What? 6? 6 times 6 times 0.5 times 4? 72?
Now do.
So that's the area? Okay, because for the area I got 72. How did you get that? Here, can I see your work?
Alright, so.
What did you do?
Oh, yes. That's basically, yeah. I see what-
Equals 72.
No.
Yeah, then we have to do the square root.
Okay, so you can use the Pythagorean theorem to find one of
We
the
get
side
this,
lengths,
and
which is
it's
square root of 72, and then you just square it.
The area?
4, 9. No, the
Okay.
other thing is positive.
Wait, are you sure? Hold on.
No,
So-
because this is. No, we have to do this first.
No, so what I did is I got 6 and 6, and do you remember like that special triangle rule where you could do like the angle was 45? So I found that was 4.24, so the square you could do
The
4.24 square, and then I got like
2
10 squares.
sixes, like.
Okay, so.
How did you get
6
72?
6.
I was doing that, and then you just square it.
6.
And the square root of 72 squared is 70.
Wait, so like
Yeah,
what did you
6
do?
radical 2. It's the same thing. So that's how you would get it. And it's 8.
To find the area of this triangle, it'd be 6 times 6 times half to get the area of a triangle, and then we multiply it by 4.
Wait, Mr. Hudson, isn't it like dropping an altitude that you multiply the triangle by? Not another side.
Have you asked this question in class?
Hunt.
Yeah, so.
So you need to say a couple more words. Why are you doing 6 times 6 times half?
To find the area.
Area of a triangle, but I did it wrong, so.
Well,
No, wait. No, because it is.
I thought you dropped the altitude. No, we're trying to find a second method.
you two are thinking in different
No,
ways.
so, guys, we
What
haven't
Hunter's
done the first
saying.
one yet.
I almost don't want to fill this in for you. What angle is created at the center?
900 degrees.
So
And
you're doing 6 times 6 because that's your base and your height of the little dudes.
Oh, you're in the little dude.
yeah.
Oh.
You gotta say the words that are in your head. Like, I know what you're thinking. I've been through this, right? You gotta say it.
Okay. So, yeah.
Ah.
90 degrees. And so, yes, this.
I'm still wondering how you got 72 though.
Maybe I did the math wrong because I did it in my head.
No, I just did.
So this has to be 18, 18, so just 18 and 4 is 72.
Wait. So
So let's do it Sasha's way. So, we do Pythagorean theorem.
no, I didn't do Pythagorean theorem.
What did you do?
Okay, so do you know how like if you have like a triangle that's like that, and like that's 45, that's 45, and that's 90, and that's where's it? Okay, so
So
these
it's 6 radical
these two
2.
sides are 6, so it'll be 6. No, I'd press the divide button.
6 radical 2, 8 point, that would be 49. So, now what? No.
So this is 8. Square that.
8.49. Yes, square.
Wait, no.
Yeah.
Yeah. Hold on, I want to check to see if what did I do wrong? Yep, there's a mistake. Hey, Mr. Hudson, do you want to know what I did wrong?
I mean, sure, but I don't really need to be involved. I heard that and listened to everything you guys are doing.
Oh, that sounds good.
I'm just trying really hard not to talk.
Okay, so for this first one, let's just do it the way that we've done it before.
What first one?
Connect it for this first.
Oh, the first method? Wait, I have an idea.
Let's just connect all of these.
Could you like rearrange it so it makes like a not a hold on.
Wouldn't this like this be?
I mean, you might be able to, but
Quit asking as if you're looking for permission.
Okay, let's see.
Start saying what if.
oh,
What if we try is so much better than can we? It's like you're asking for permission. Don't do that.
So if we divide it up into right triangles,
Mr. Hudson, would this work?
Talk to your team.
That each of these two makes a rect.
No, what I'm asking is, like, could you cut them in half? Put it over here. Now take this side. Hold on. So can it, okay, so then
what are you doing? So you're taking this top and putting it over here.
yes, now I got 8, 8, 60, 60. Is there a way to find the area for turn?
What do you mean, is there a way?
Yes.
What did he do?
I remember in some way.
You still have this square.
No. I tried like cutting the hexagon.
Thomas, you know, you could join a team and let your brain power help other
You
people.
average these and then multiply.
Wait, it's literally just 60 times 8. So a parallelogram is just.
Quit looking at me. You're talking to your
So
team.
the way you solve a parallelogram is taking this side multiplied by that side.
Base times height.
That's literally yeah. This isn't height though. 'Cause
No.
this isn't height.
Okay.
This is height.
So this is a trapezoid.
Quit looking at me.
This is a trapezoid.
Everyone look
Yes.
at Mr. Hudson.
Jacob, stereo.
This is a trapezoid.
Yes.
Jacob,
And the
stare
trap.
at Mr. Hudson.
Average the bases.
And he's gonna stare back, and that's scary.
Yeah, we do have to find the height.
Yes, you have to find the height of that.
So let's see.
So you can do pi.
No wait, hold on.
I am holding on.
Here we go.
It's not scary. It's just
If we find this, then we know the height. If we're gonna do this. So
I'm just trying not to
360
talk.
divided by 6.
Talks about talking. Talks about not talking.
360 divided by 6.
The approximately 6.9. I think
So-
the height.
30. So we do.
I think the height would be 6.9. That could be frosted.
just for that.
6.9. What? Pythagorean theorem.
Just dropping altitude, well, like
Well, you can make
angle
two
get
trapezoids.
exactly half. Before 4.
Yes, but that sucks.
On this side,
So,
So let's try the rectangle.
what about
Two weird
pentagons?
triangles.
Guys, I made pentagons.
Mhm.
I don't
The
know.
first-
Okay.
Wait, are you guys already on 34?
Yeah. 34 isn't even quite.
Yeah, so our lateral, so it should be 8.
You're on 35.
But it, no, they're isosceles, not equilateral.
So wait, this
No,
kind
wait.
of rectangle is just
No, they are
maybe
because
twice the height
yeah,
of
they're on.
the
Okay, so we
equilateral.
already got-
Yes, they are 8.
45.
So
We
the height
already got this
should
one.
be-
We need a
So
second method.
the height or the area of the rectangle is going to be 8 times.
We're trying to.
We're trying to, we're just like, okay, so yeah. Yeah, so it's 6.
Because isn't
16 times 6.9.
Yeah, that's not.
Yes, then,
These are 120.
okay, so I would leave this would be a 30, so then it makes 36 triangles, so the height is actually 4.
Jacob's
The
carrying
height
this.
of this is, the height of this is 4.
Yeah, and then rectangle is just going to be
And this
double.
would be,
Wait, what?
the rectangle would be what?
So the rectangle is
8
going to
right?
be
6.9 3 times 6.
I don't have the calculator.
6.9 3 times 6.
Hunter took my calculator.
This is 8, this is 4.
Look
That's
at that.
one
This-
method,
this
and
one
then
would
you
be
use
four.
your method too.
So we have 2 methods for this.
No, that's the same thing.
No, it's
Yeah,
not.
this entire
Well,
side is 8 right?
Okay.
It's finding the area of this triangle and multiplying it by 8. Yours is a trapezoid.
And then what did you find?
Wait, that was my idea.
Then the triangles that would be 4 times 8.
Yeah, okay, anyway.
Yeah.
32.
And then
Now let's do hunters.
double that.
60.
Oh.
I drew that. Terrible.
Wait, no,
Wait,
no,
that's
it's 4 times
awful.
4 right up to 3.
Terrifying.
60 and radical 3.
And then double that. 32.
Mr. Hudson.
And then you can add them
Don't
all.
ask
It doesn't
Mr. Hudson.
exist.
What?
So yeah,
There's no teaching.
So there is no way I could find if I had a triangle that's like this.
And then, yeah, 96.
Could I find out any information?
I'm sure you could.
I don't know that angle. I don't know that angle. I don't know these two sides.
Oh, it looks like I can't
Anybody comfortable to show their work from A square?
This is this.
Nah. Put it on the camera.
Oh, yeah.
All right, Levi, talk us through what you did.
This is
Um,
Pythagorean theorem. This ends up
I'm folding your notes. Sorry, Levi.
It's okay. I'm using the same note sheet.
0.93-ish. 0.93 times 16.
All right, so Levi, you and I'm guessing maybe your group did what?
Well, I did 8. I showed them how to do it. So, I knew segment was 6, so I added them, so I made a diagonal, and
Okay.
I knew that was 12.
Okay.
So I did base times height, but I didn't have to divide it by 2 because it's not a triangle. So I'm finding the area of the square.
Okay.
It's half the area of the square. So then if you just double it by.
So what about the other one then?
Wait, can I say?
I mean, I did that one.
For that one, we just Pythagorean.
We got one of the sides with Pythagorean, which was radical 72, and then
That's
the square root of 72.
Can I say?
If we I like this is really creative. I'll let you show yours too. But if we look at finding this third side, that's your hypotenuse. So 6 squared plus 6 squared equals c squared. But so to find the c, we take the square root. But then to find the area, we square it. And yeah, it's just so we get 72.
Really
What
don't
else?
understand. So wait, hold on, wait.
Explain it.
Okay, so what I.
What do you mean?
Dang, I know.
Did you even
I-
use the template?
Hey, be nice. And no, he did not.
I did not. Okay, so what I did is I knew that most of the sides of that triangle were 6, and so I did that little rule that for if you had a 45, 45, and 90-degree triangle, you could like multiply it by the square root of 2. So I did that, and it didn't get 4.224. I accidentally pressed the divide button instead of the multiplication button, so I got something like I think it was 8, and then I multiplied that by itself.
Does that make sense?
Yeah.
At least some.
I have
Moderate.
writing.
Moderate sense.
So what about for B? You know, comfortable, show the Thomas, can I have it?
Yeah, it's kind of messy though.
Well, you got to talk us through it
Better
then.
than me.
Okay,
Thomas says his is kind of messy. Okay.
first thing, and then it goes down all the way to the
Okay.
bottom.
So this.
So what I did first was I know that all 6 of those angles in the middle add up to 360, so I took 360 and divided by 6, about 60. And I know that all of those angles at the edges of each of the little triangles are congruent. So 180 minus 60 equals 120, and then divide it by 2, and you got all of the angle measures for all the triangles. And then you can find the area of the triangle through Pythagorean theory words. And
So dropped an altitude,
yeah.
right? Dropped an altitude. Used the Pythagorean.
And then
Found the area of 1. Multiply by 6.
And then for the other one, I just did it grouped together with 3 triangles.
Now I heard some really creative discussions. That was really good. I heard some really creative discussions here, especially. Did you guys get to an end point of that?
Yes, but we did them weirdly.
Can I borrow
Something
this?
is wrong. I sure hope you
Please.
can.
So, check this idea. If we take our hexagon, split it, and honestly, you could actually just split it across the middle into 2 trapezoids. If I bring this trapezoid down and stick it on the end of that trapezoid, we create a parallelogram.
Huh.
So you can take a hexagon, cut it in half, and just make a parallelogram. And of course, to find the area of a parallelogram, it is base times height, just like a rectangle. So now your challenge becomes with this problem, they each give you a different part of the polygon.
I feel like this is
Edge length here, altitude there, radius here. And that is what we call the radius of the polygon. It goes from the center point to the edge point.
23.
Are you getting us ready?
I'm going to give you at least 10 minutes, probably more, because there's 3 of these and they each solve different.
Wait, is that?
We just have to solve these ones once.
Wait, is 7 gone? What?
I mean,
1, 2,
if you
3, 4.
can solve it multiple ways, you might as well.
That's the first one's 7.
But if we screw it up and do everything,
Oh wait, I can't. Which one's the non-gone?
A is a non-gone.
No. Oh, 23. Okay.
I love those shapes templates.
They're so easy and
That one's
nice.
just a normal hexagon.
Nice and neat. Could you do like the thing that you do with hexagons? So that's 11. You could just do 11, wait. Yeah, 11 times the square root of 2. So 11 radical 2. And then you can... Wait, are we finding... What are we finding? Area?
No.
Again, stop looking at me. Could have asked a classmate that question.
Okay, so Chris, does it make sense?
I'm drawing another triangle.
It doesn't work that way.
Well, it doesn't, but I don't feel like measuring it. Well, I mean, if I call something an altitude and it looks relatively like an altitude, and I give it a marking that says it's an altitude, it's an altitude.
No.
He is right.
It does bend to my
He
will.
is right.
Math.
Because mathematically, this is why I love math. It is. I say it is.
You
It
just have to write,
is.
this is not the scale at all. Don't trust it.
Yeah. Don't trust anything like. Yeah.
Trust the markings. Trust the markings, not what it looks like.
I don't have a calculator.
I sure hope...
You sure can. Anyone else for a calculator? I've got a plenty.
Alright, so are we doing the non-gun together, or are we just gonna like...
Oh my goodness, I can't.
Oh, I'm doing it on gone.
So we're not even gonna do it together, like we should be doing?
Oh,
Wait. False.
wait, I want to find that angle, so that would be opposite.
Be quiet. I'll make a kite.
Sine is opposite
Don't
of
make me feel
so.
special.
So yeah, we can do trigonometry to find.
That's not
do
44.
trigonometry to find this. So that's opposite over hypotenuse. So that's sine.
That doesn't look right. Chris, this doesn't look right.
X over 11.
Oh wait, so that's 44.
It's 45.
Like what? 45. Okay.
Are these
Then
regular?
we can use that angle, so we could do.
Okay.
They're regular.
Tan,
Just making sure.
Yes, I'm not evil.
Yeah, it's like.
tan
I'll
of
figure it out
45
otherwise.
times. So it's tan of 45 times
And then he's like, yeah, it's not
opposite
regular.
over adjacent. So tan of 45
11 sine 45.
divided by 7.775. This side. No, that's not right. 7.775.
So actually, can you like stop working ahead when we're trying to be doing this?
And out loud, right?
Yeah. Like boy. 11 sine 45 is 9.
Well, now you're just working out loud.
6.
Teacher, I'll always work on your paper.
Yeah.
It helps you pay attention.
We do trigonometry. We can do sine 45 because x over 11. Because we know this has to be isosceles, so this has to be 45 degrees. No, they should be equal. Not 45.
Wait, if we got okay, to basically make them equal.
So really, we don't know what they are.
7.775.
If they're 45,
That side is 7. That side is 7.775. That's easy what the calculator
This
said.
has for the interior.
Yes.
Because it was 45 degrees.
Mm-hmm.
we don't know it's 45 degrees.
Yes, we
If it's
did.
45 degrees, then this would equal this. This would equal this times half. It's not 45.
So how did we get?
Hey guys, what was that equation we found? It was n minus 180 or something.
N minus
Yeah,
2
we can
times
just do
180.
this one.
Okay, they're 140 and they're split in half. So sure.
N minus. Wait, it's N minus.
N minus 2 times 180.
Yeah, you could have just asked.
So 7 times 180 was 12.
It's been only like a month and I forgot how to do
1260, and then we divide it by 9.
You
We
just
know
said
the
like a
two
really
base
good-
angles must equal 70. There. So yeah, we have two base angles equal 70. Verify this. Some theorem by dividing 360 by 9. And then
Oh, I'm in the wrong mode. That's why I didn't show.
yeah, so yes. So base angles are 70. Guys,
No,
let's get all that.
Tan of 40.
So now we do sine 70 equals x over 11.
No, this side has to be 7.75. That's what even what the calculator said.
Well, what did you put in to get the calculator to say that?
Tan of 45 times 7.
It's not 45.
It was like 44. No, Satya. Okay, Satya. The base. There are no 45 angles. Hold on. Satya. Hold on. Where did we get that, Satya? Did we know that the interior angles, this whole thing, equals 360? Actually, I'll grab one. This whole thing equals 360 divided by 9. That's 40. And then divided by 2. And we're making this. This is 20. These are both 70 there. So this is 70. This is 7, right? Nick, 35. So it's 20. So I just do tan of 20 divided by. No. So, look, it's not tan. Yes, opposite over adjacent. So we could do tan. You don't know it's 7.775 because you didn't do. Oh yeah, I did the wrong angle. So 11 sine of 70 is what I'm doing. Right? Sine of 70 equals x over 11. So 11 sine 70 equals x. X.
Wow.
What?
If you want an interesting graph,
5, 1, 3.
I'm trying to occupy myself so I don't engage with you because I want you guys engaging with each other. This graph shows the growth of disc golf courses in America. I'm writing another grant related to disc golf. Just look at the ridiculous upswing from 95 to 2000, and so this would only be 2005. I can only imagine where the graph went beyond that.
Probably went. It looks like it's just going straight, like not straight up, like at a 45 degree angle.
Yeah, like steady increase.
I was having fun, so I made it.
Looking for Chromebooks or what?
Now I have trapezoids too.
Sure. What do you need done? That might.
Just to reach into the Chromebook cart, I can't reach all the way in there.
Okay, so now we've done that.
Lauren, this is amazing.
Now
Wait, hold on, more smile.
So now we can do tangent. I'm gonna do tangent of 20.
That is
Equals x over 8.513.
big triangle in the center. This is the area of the big triangle in the center.
Equals.
Okay, so I'll leave that now.
I'm gonna do the octagon real quick. 4 or 5. B is an octagon. So wait, 1, 2, 3, 4, 5, 6, 7, 8. Hold on. 1, 2, 3, 1, 2, 3, 4, 5. No.
I don't know.
Wait, Lauren, Saki, did you get an answer for someone?
No, Chris is doing that.
I'm getting all of my work inside of it.
I'm sorry.
No.
Okay, so this is the
Are you afraid of getting a new piece of paper? Okay. Do you have the height of the trapezoid?
the height of trapezoid is 5.5.
I don't have any of the bits.
All that 300.07. Divide 300 times 9, 3, 4, 5, 6, 729.6. So it's 36. That means that's 2 4 units squared.
I don't know.
Literally 11.
I don't know what I did. Salted tears in my eyes.
Okay.
Darn it.
Yeah, that'd be
Where'd you get this? This is 25. Yeah, it's not 45. There's no 45.
Oh, it's right here.
Nope, that's not 45.
Yeah, it is.
No, because that was 45, and this line here would have to equal half of this.
No, because
Yes.
these two lines are the same length, so they should be.
Yeah, but that doesn't necessarily matter. It just means they're equal, not that they're 45. Chris, like imagine you could have one that's like this. This isn't. You could have one that's like this. This isn't 45.
Wait, I had almost 100.
What about like this?
I got 834.
And then it'd be
That's not a triangle.
Imagine it's
plus
shape
the answer from here.
area inside of my hand.
One of us is extreme.
It's an isosceles
I
triangle.
got like
These
700,
pretty sure.
then I got 900.
Okay. We're all over the place.
right? right? Here, here's the
Mr.
protractor.
You need a help us?
And measure my finger.
Would you like help?
I would like you to just look at mine.
Fine.
I would like you to
First
just
I
look
got
at
9
mine.
areas
Mr. Hush.
Just look at it?
I'd
Like
like
that's
you
it?
just to see it.
Wait, for the answers for
I
me,
will
you
lay
guys
eyes
say
on
1
it.
point. These
Although,
49.
come on.
I was a jerk and told
Lauren.
James on the easy way, so he had to do
Lauren,
something.
there's no way this is 14.4.
Yeah.
It's way higher. Yeah, so it's definitely not that. So scrap whatever you said about that.
Dang,
Okay,
okay.
I found this center triangle.
No,
I like
they're
made
very
that half, and then this is like created 3 trapezoids. and
Which
then
not
this
45?
The
non-sections or-
It's the non-gone.
Wait, have you guys gotten B done yet?
Yeah.
Which one I got all of
I made it
What did you get to B? I just want to check
How
out
do you
your
find a
essay.
center triangle with a non?
Oh,
that's a trapezoid, right?
Yeah.
Okay, so you make trapezoid.
This whole thing
Yeah.
has to equal 6, right?
Yeah.
So you divide
Split
it
it
by
into
9.
3 parts. Put each of these
Split it in half. How would you not get this?
And then
Therefore,
I
just must
made
equal 7. That's twice anymore.
Yes.
Hold on, what is your answer?
They're the same. So this, I don't know what you
So,
do.
I like what you're doing.
It's not
Creative
45.
solution.
Except it's like
It can't be
two-
45
making it
because
super complicated.
there are 9 angles here that have to equal 360.
Oh,
360 divided by 9 equals 40. Okay?
And a 16.
So this top end over here,
So
the total is 40. Divided by 2 because
so
you're dropping
all that
angles
adds
here,
up to
so
360,
20 and 20.
That means that is 10, right?
Triangle angle times 0
Not
is
10,
36.
36.
That these two angles therefore must
So
equal
that'll
7
be 8.
because you're dropping it
I-
on 2.
Divided by 2 equals 18, not 16.
I can do all of this stuff, but it can't
Can't
do
use
division.
the graph. Actually, I think that's the calculator I used during the math counts competition. Let me see this.
Oh.
Yeah, it is. It is the calculator I used.
They didn't clear our calculators at the math count.
They didn't. We
Which
could have
was
put on
so dumb.
all of the answers. They took away
Well, there's no way to
they
get
took
the answers
away
ahead of
the
time.
paper that we brought, but they didn't
They
clear
took the blank
calculators.
paper. They took my ring, but oh no, we are not going to clear
Wait, why
your
did you keep your ring?
Because I don't even know. Did you take?
There was a headphone in the ring, and she was gonna. Okay, what is the square root of 64?
Yeah.
Okay, so I wanted to ask you a question based off our parallelogram that we found in that last problem. So we know that we can split all these shapes up from their center point into these triangles, and from the conversations I've been observing from you guys, I think we're pretty good at taking the 360, dividing it into as many triangles as we have, figuring out the base angles based off that, dropping an altitude, if we don't have one already, using trig to find our unknowns, all of that, great. But my question for you is, can every regular polygon turn into a parallelogram? And if not, is there something that they can't?
Every parallelogram with even sides can.
Yes, every regular thing can. And I
Nine.
can't show
So
why.
the non-gon can turn into a parallelogram?
Yes.
That's an odd number of sides.
Can I see? Can I go?
You can turn
That
into triangles.
Be a big trapezoid, but
Think so.
Seven straight
It would be a trapezoid. It would be a
Yeah.
trapezoid.
So not
You can turn everything into
parallelogram.
triangles.
It wouldn't be a
Trapezoid.
parallelogram, but it would be a trapezoid.
Which is
Yes.
not a parallelogram.
So be careful with your answer. So that's what I'm trying to get you guys to. So Jacob,
Okay, fine.
I like what you're doing over there. It's very creative. It's beautiful, honestly. But if you want another route that we can take, we can always make it into either a parallelogram or a trapezoid.
don't tell him this now. He's too far gone.
So if you
Wait,
want
hold on.
to check your answers,
Okay, please.
What do you do? Okay, so first I did it like this. Then I made 3 trapezoids and like 7 triangles.
Oh, no!
Okay.
And then, okay, but I did find the area of the center triangle.
Okay, so do you want to know what I did?
Oh.
Do you want to know what I did?
What?
Do you want to know what I did? Do you know what I
if
did?
you made a mistake,
Doesn't involve making triangles out of everything.
Do you know what I did?
Okay.
Hold up. We have 8 minutes left. Gentlemen, come back to me. Come back to me. Come back. Okay. If you made a mistake, try to find it. If your answer doesn't correspond with those answers up there, find it. This, getting through 35, is as far as we're trying to go today. Notice over on the homework board, we're splitting the 822 homework. So actually, my bad when I agreed with someone when they said it's just the 822 homework. I mean, yes, but we're splitting it to 2 days. So you can do it all tonight if you want, but tonight 39 through 45, tomorrow will be 46 through 52.
Oh, wait.
So check your ABC. If you made a mistake, find it right now. Well, then keep going, keep trying.
Wait, so can I do the homework now if I got them all right?
If you did A, B, and C and all that makes sense, then yeah, because then you're ready for the homework.
I want to show Jacob one thing really quick.
That's fine. Yeah, you're good. Forewarning, they're doing the simulation on repetitive room today. It's about to get very loud.
Yeah.
I remember doing that.
You're doing the one with the shield and
Okay, so that's square. You know, each side of 5. It was 5. So what it is that I drew a circle sign to figure out each different. Okay. So what I squared, and I knew that this side was 5. So what I did is I drew a circle inside of it, and I created 3 different trapezoids to figure out the area of that circle. Then I multiplied that by the trapezoid.
Now the question is, did it work?
No.
Now multiply by the mass of the sun.
multiply by the trigonometry of calculus, and then you'll get the right answer.
Now, for those of you who don't come to math counts, I also want to take the last bit of time right here to pitch an idea at you that could be worth a vacation to Florida and $1,000. The Math Counts Video Challenge is a branch of the Math Counts program that has a packet full of problems, and a lot of them aren't that hard, that then you make some sort of video off of, and you enter under 5 minutes, you enter it in the contest. So your team can be up to 4 people. The reason I'm pitching this right now is we have Discovery Days coming up, and if you don't have a good Discovery Day idea, this could be a great 2-day plan. The winning 4 teams, or the top 4 teams, get an all-expense-paid trip to Florida to the National Math Counts Contest, and there the winning video team will be announced and will get $1,000 scholarships each. So, as you know how... Yes.
They're not going to make you pay your own. So
You can come to Florida, but we're not paying you.
You won?
Not 100% sure, but I mean, I'm sure they would like. So we watched a couple yesterday in Math Counts, but I wanted to show another one. So the 2016 video here.
We didn't see this one.
We did not see this one. So they start by showing their problem, like what the actual problem. You don't have to do this; it just has to relate to the problem.
Wait, so do you have to
So
make
you
video
just choose one problem.
Yeah, you have
and
to
do
do
it
one problem. Yeah.
But it has to be from this booklet,
Yeah.
not the
Oh,
one we've
yeah.
already done.
Getting down 24. Hey, hey, it's your girl, Galaxy Galore. Today we're doing the Hashtag Marble Challenge. Have you played this game before? No, I haven't. First you're gonna need 39 marbles, 2 people playing now. Here are the rules.
Just happen to have 39 marbles.
Exactly 39. Bobby had 73 bombs of this one.